Power series. A power series is a series in which each term is a power function. Below are some examples. The series that goes from 0 to infinity of x to the n, that's x to the 0 power plus x to the first power plus x to the second power, and so on. Or the series from 1 to infinity of 3x to the n divided by n factorial. So that's 3x to the first power over 1 factorial plus 3x to the second power over 2 factorial, and so on. And even the series from 1 to infinity of 2 times the quantity 1 minus x raised to the n power. So that's 2 times 1 minus x to the first plus 2 times 1 minus x to the second, and so on. Given a power series, only one of three things can happen. The first thing is that the series will converge only when x is equal to a. If x is equal to a, then we'll have a minus a, so that will be the series of all zeros, which converges to 0. The series could also converge for all values of x, meaning that whatever value of x we put in, it would lead to a series that would converge. Or finally, there could be a positive number r, such that the series converges when the absolute value of x minus a is less than r. This r is referred to as the radius of convergence, and the interval from negative r plus a to positive r plus a is called the interval of convergence. Well, how do we determine convergence? Well, to find where a series is said to converge absolutely, we start with the conditions of convergence for the ratio test. That is, we check to see if the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n is less than 1. If we find such an interval and it's finite, then we'll test convergence at the endpoints. The series may have what's called conditional convergence at the endpoints. Once we find this interval of convergence, we know that the series will converge for all values of x inside the interval and diverge everywhere else. We'll look at some examples, and for each we want to determine the radius of convergence, the interval of convergence, values of x for which the series converges absolutely, and values, if any, for which the series converges conditionally. Example 1, we'll look at the series that goes from n equals 1 to infinity of x to the n. We'll first start with the condition of convergence for the ratio test. That is, check to see if the limit as n approaches infinity of an plus 1 divided by an is less than 1. We'll check for the limit as n approaches infinity in this example of x to the n plus 1 power divided by x to the n power. X to the n plus 1 power can be rewritten as x to the n power times x to the first power, and that's still divided by x to the n. I cancel a factor of x to the n in both the numerator and the denominator, and I end up with the limit as n approaches infinity of the absolute value of x. Well, because there are no n's in the absolute value of just x, that limit is equal to the absolute value of x. For convergence, I need for the absolute value of x to be less than 1. Well, solving that inequality, this means that x must be sandwiched between negative 1 and positive 1. So I expect convergence for values of x between negative 1 and positive 1. But we may also get convergence at the endpoints, negative 1, or at the other endpoint, positive 1. So we have to check. When x is 1, the series becomes the sum from 1 to infinity of 1 to the n. This series diverges. When x is negative 1, the series becomes the sum from 1 to infinity of negative 1 to the n, which also diverges. Therefore, I don't get any conditional convergence at the endpoints. So now I'm able to answer the question. My radius of convergence is r is equal to 1. My interval of convergence is negative 1 to 1. Values for which x converge absolutely are negative 1 to 1. And values for which there is conditional convergence, I do not get any. Example 2, I'm asked to consider the series from 1 to infinity of the quantity 3x minus 2 to the n divided by n. I again start with the conditions of convergence for the ratio test. And in this example, I have 3x minus 2 raised to the n plus 1 divided by n plus 1, and all of that divided by 3x minus 2 to the n divided by n. Simplifying that complex fraction, I have 3x minus 2 to the n power times 3x minus 2 to the first power, all divided by n plus 1, times the reciprocal of the fraction that was on the bottom, n divided by 3x minus 2 to the n power. My 3x minus 2's to the n power cancel, and I'm left with just 3x minus 2 and also n divided by n plus 1. As n goes to infinity, 3x minus 2 remains the same, and using L'Hopital's rule will let me know that n divided by n plus 1, that limit is equal to 1. So in the end, my limit is simply the absolute value of 3x minus 2. For convergence, I must have that the absolute value of 3x minus 2 is less than 1. Well, this means that 3x minus 2 is sandwiched between -1 and +1, or adding 2 throughout the inequality and then dividing by 3, I get that 1/3 is less than x, which is less than 1. So I expect convergence for values of x between 1/3 and 1, but I may also get convergence at the endpoints 1/3 and +1. So I'll check. When x equals 1/3, the series becomes -1 to the n divided by n. Well, I know that this series converges by the alternating series test. When x equals 1, the series becomes the sum from 1 to infinity of 1 to the n divided by n, which I know diverges. So I get conditional convergence at the left endpoint x equals 1/3 and divergence at the right endpoint x equals 1. So now I'm able to determine the following. I know that my radius of convergence is equal to 1/3. My interval of convergence is 1/3 less than or equal to x, which is strictly less than 1. I have less than or equal to in this interval because I picked up additional convergence at the endpoint 1/3. Values of x for which the series converges absolutely are between 1/3 and 1 in points not included, and the values of x for which the series converges conditionally is x is equal to 1/3. Example 3, I'm asked to find the interval of convergence, and this time the sum of the series from 0 to infinity of x minus 1 divided by 4, that quantity to the n power. I'll start by writing out the first 3 terms of the series and observe that it is geometric. My first term is x minus 1 over 4 to the 0, then x minus 1 over 4 to the first, x minus 1 over 4 to the second, and so on. And that reduces to 1 plus x minus 1 to the first plus x minus 1 to the second, and so on. So I can see that the series is geometric and the ratio is equal to x minus 1 over 4. Well, geometric series converge when the ratio is less than 1. That is, when the absolute value of x minus 1 over 4 is less than 1, or when the absolute value of x minus 1 is less than 4. Solving that inequality, I get convergence when x is between -3 and +5. Well, the sum of geometric series is a, the first term, divided by 1 minus r, the ratio. So in this case, the sum of the series is equal to a, the first term of the series was 1, divided by 1 minus r, and r was equal to x minus 1 over 4. Simplifying, I find that the sum is equal to 4 divided by 5 minus x.